About 20 years ago, I got interested in kaleidoscopes. I started collecting them and I started writing software that simulated kaleidoscopes. There's a lot of videos out there, particularly for p5.js, that show how to do a kaleidoscope effect. And I just wanted to talk about some of the specific things I do in my kaleidoscope simulations that please me. One of my goals is to do a simulation of a specific antique kaleidoscope called the Bush Kaleidoscope that was a relatively popular kaleidoscope that was sold in stores in the 19th century. It had an object cell that contained blown glass ampules, some of which contained fluid, and each kaleidoscope included a glass swan. I'm going to show a few of the kaleidoscopes in my small collection. This is a little cheap toy scope. It's got 3 mirrors and the object cell has a bunch of little plastic trinkets in it. There's no fluid in it. And this is what it looks like. I'm not a huge fan of 3-mirror equilateral triangle configurations, which is very common in cheap kaleidoscopes. This marble scope also has a 3-mirror configuration, as you can see, and it's kind of repetitive, you know. That's what it looks like. There's a marble on the end that you're looking through. The marble is also doesn't have a lot of variety to what you're seeing when you look at the marble. This kaleidoscope has a 2-mirror configuration, which I like better, but the object cell is a fixed piece of stained glass, which repeats when you spin it. Let's see if we can get a look at it. It's very hard to do. There it goes. So you'll see that as I spin it, there's a red thing coming up right there. Let me get it in view, sorry. Let's do it on the phone. So you'll see that it's repeating as it rotates. There's a fixed set of things you're looking at, and the cycle is relatively short. This one, also a 2-mirror scope. It's a little better, a little hard to see, unfortunately. But it's got 2 things that are spinning, so you get a little more variety because you're getting the combination of the 2 things, but still not great. My favorite scopes are ones that have fluid in them, preferably mineral oil, with free-floating objects. This one is very hard to see, but let's take a look at it. You get the effect of gravity on the objects as they fall either towards the center of the scope or they fall out, depending on how the mirrors are currently arranged. And that effect of seeing the objects moving at different speeds is pleasing. And here's another scope that also has fluid in it with clear marbles. And it also has a nice effect from gravity. So those are my favorites. So when I'm doing recreational coding and I'm making kaleidoscope simulations, I like to try to simulate the properties of kaleidoscopes that I like. And that means having object cells where objects are moving at different speeds, having a simulation that involves gravity and viscosity is nice in the object cell. I prefer 2-mirror arrangements to equilateral triangle 3-mirror arrangements. And there's a few other tricks I have up my sleeve, which I'll show in a moment. I'm currently working on a set of recreational sketches in p5.js. These are ports of older programs that I wrote in classic processing. There's a link to a GitHub repo that has all this source code in the description. I'm not going to go through the source code line by line because that's boring, but if you have any specific questions about it, feel free to ask them in the comments and I'll reply. But I will be talking about the main features in the code. All these sketches make use of a common JavaScript class which provides a bank of sliders and buttons. This bank is designed to work with MIDI control. So if you have a MIDI controller like this one, you can get the sliders to respond to these knobs and buttons. If you hold down the Shift key while pressing a slider and then tweak one of the MIDI knobs, it'll learn that that knob is associated with that slider or that button is associated with that button. And you can teach it about your specific controller and it will remember that information. The nice thing about using a MIDI control surface like this is that you can use two hands and tweak multiple knobs at once, which is why I like modular synthesizers for the same reason. And you can get more interesting effects that way. This is the main directory that has the current projects. There is something called Rose Synth, which is a Whitney music box, although it has a button that'll toggle between that and the Rose equation. You can, which is similar to the Whitney music box. I'll cover that in another video. I'm using a several dot version of the Rose equation, which has dots moving at different speeds. In the kaleidoscope I'm about to show you, this is the Rose Kaleidoscope. If I turn off the mirror, you can see that it is, and I turn off the blur, maybe shorten the dot radius. You can see that it's essentially a Rose equation that's moving very slowly. You can control the speed and things like that. And then I typically have it blurred a bit. And by basically tweaking these two sliders, you can kind of get interesting things going on. Control the dot radius. And I like it if the speed's going relatively slow. When I turn the mirrors on, then you get the full kaleidoscope effect. If there's a wedge button, so you can see the current mirror arrangement. This controls the number of sides in the kaleidoscope. And so you have, I kind of like prime number arrangements for like 5 sides or 7 sides. But a very popular one, of course, is 6 sides or 8 sides. There's a 6-sided kaleidoscope. So the wedge is 360 divided by 12, which gives you a 6-sided figure. So you multiply the number of sides by 2 to get the number of wedges that you need. There is a trick I'm using, which is important, which is that I am the wedge that I'm copying has the same slope line on both sides. When I originally was doing these, I would use one edge would be straight and the other one would be at a slope. And the problem with that is that you get different aliasing artifacts on the two sides. So by having the two sides of the wedge at a similar reflected slope, you get similar aliasing artifacts and it looks a little better. A very common problem with kaleidoscopes is getting very thin lines on the boundaries. And there's sort of a trade-off between getting rid of those and having good alignment on the edges between the reflections. Very difficult to get that precise in real kaleidoscopes. So finally, there's one other thing I'm doing, which is I support feedback. And this is an interesting topic. I learned about this about 20 years ago from someone named Marshall Yeager, who developed a physical device called a kaleidoplex that was used for some concerts, for organ concerts. And the kaleidoplex essentially was one kaleidoscope feeding into another kaleidoscope and then being projected. And so that is supported here. So if I turn on one feedback level, you can get the effect of that. So what you're seeing is, let me see, there's one level between that now. Yeah. So what you're seeing essentially is a kaleidoscope made of kaleidoscopes. You can control the scaling on the second kaleidoscope here. I kind of like it closer to the edge there. And it generally looks better with fewer sides. Yeager's device typically had a 8-sided configuration like this. This is somewhat close to what he's getting. If I have time, I'll insert some video of the actual device. There's some DVDs of a Virgil Fox tribute concert that use it. So this is a cool effect, and it's a kaleidoscope going into a kaleidoscope. That's one level, but you can also have 2 levels, 3 levels, and the more levels you have, it starts to get, and the more sides you have, it gets very intricate, but also gets more static. Kind of like a rug. So there's a trade-off there. I tend to prefer fewer recursion levels, just 1 or 2 is enough. There we go. That's pretty nice. So the one thing I haven't shown is adding the effect of gravity. I'll do that in a separate video and show construction of an object cell that uses gravity, which makes the kaleidoscope look much nicer, in my opinion, than just the straight up Rose equation that I'm using here does. See you soon.